So great to see everyone. Welcome back. Glad to have you here at our monthly webinar. And we're starting off just looking at what happened last month. So not such a bad month after all, even though we're looking at one of these maps that shows a lot of those kind of red colors that tell us that most of the temperatures in March were above normal conditions. Still not a bad month after all. We did have some good precipitation, but still temperatures were still above average most of the locations. If we look at the rankings, Pinal came in as the county with the highest ranking. It was their 17th hottest March on record. Maricopa tied for its 18th hottest March on record. So although Phoenix didn't reach 100 degrees until this April 10th, last month, March 25th, last month, we did see 99 degrees in Phoenix and 96 degrees in Tucson. FYI, that the next day, on April 11th, right after we hit 100 degrees in April, Phoenix reached 103 that day. Grateful the rest of April has been a little bit cooler. If we're looking at March for our precipitation, we were grateful again. March had several systems cooler and wetter across the state, and that lasted until about mid-March. The state did have a bit more precipitation that first part of April this month as well, but so far April's been fairly dry ever since. We'll go back to March. Most of March precipitation landed in more central counties, but grateful that the precipitation came in the form of snow in several locations at higher elevations, so not too bad. I do want to take a look at what's been going on for the past 6 months for water year 2025, and we're looking at temperature conditions overall statewide. The fifth hottest October to March on record. When you're looking at some of those colors that we're looking at on the map, those are showing individual weather stations and their rankings from October 1st through March 31st. You can see the rankings per month. These are statewide rankings when we look at those. I mean, if we go back to it, October last year, we had a record-breaking heat wave. We were ending that up from September into the 1st of October. So October really ended as the hottest October on record for the state. And you may remember Phoenix captured 19 new maximum records from September to October for that heat wave. Tucson had 18 new max records in a row. Flagstaff had 10 new max records. Fortunately, November cooled off a little bit, but then December really hot. It ended up landing as the second hottest December on record. January cooled off, February back above average conditions, and fortunately March a little bit cooler than all of those. But you can see it's been a pretty tough water year temperature wise. And then here we're looking at precipitation water year. And you can see the same kinds of situations. October started very dry. But once that heat wave broke about mid-October, the system started to get back through. So October, November, we did get some precipitation, largely in the northern tier. And then we pop in December, very dry, January, very dry. February, we had one wet system mid-February. Grateful for that, never going to turn it away, but we really only had that one wet system in February. And then the first half of March, we did have some good systems coming in, but overall, looking at October through March statewide, the third driest on record. Looking at that precipitation that we did receive, the snowpack that we were usually paying a lot of attention to with our winter precipitation. You're looking here at snow water equivalent. We call that SWE, looking at the snowpack and how much that would melt into water, thus the snow water equivalent. And you're looking at a variety of different basins. The first one kind of in the center middle there, that's looking at the entire lower Colorado basin. And you can see that for the most part, it was much below average. And you're looking, what I what I put there in front for you to look at was when we had the highest amount of precipitation for each of these basins. It all ended up being that last event in March, so mid-March. You can see March 16th. Lower Colorado Basin, the maximum amount that we received was at 69% of median. And then you're looking at the various different basins in Arizona. Salt, Verde, Little Colorado, salt was exceptionally low. But you can see those little peaks there at the end. Those are all happening. We can see the peak, kind of the early part in February, and then the peaks that we had in March. The Verde Basin did end up ultimately kind of mid-March getting at 112% of median and then quickly melting thereafter. Little Colorado River Basin, 68% of median was their max there. So you can see for the water year precipitation, October through March, we did get some good precipitation in the upper Colorado Basin area, but for the most part, lower Colorado Basin, much, much below average. And now looking at for the statewide precipitation for the water year, and you're looking here from October through March precipitation statewide. You can see it going back and forth, back and forth. We are here with water year 2025 from October through March, 35% of the long-term precipitation. So looking at that long-term going back 1896 to present, a little over 6 inches is the long-term average. We've had 2.1 inches of precipitation for the state so far. So the third driest October through March is what that should say up there. Apologize for that. But you can see the individual months. So October was at 49% of long-term average. November was at 43% of long-term average. December didn't really even measure. They had a little bit of precipitation statewide, but not enough to measure. January, very dry. You can see 8% of the long-term amount for January. February, a little bit higher, 25% of that long-term amount for February. And then March, grateful to have close to almost 100% of what we would normally get in March. What we should all remember, though, is that our wetter winter months are going to be December, January, February. We start to dry out March, and then April, May, June, moving into the 3 driest months of the year. And because of all of those conditions that we've been talking about, our short-term drought has advanced across the state. You can see kind of looking at what's been going on every month. So starting October 1st and moving through January, February, March, and April. And the short-term drought report that was published this morning gave us, unfortunately, a bit more of that exceptional drought. You can see predominantly in Cochise County, it's moving into Santa Cruz, Graham, and Greenlee counties right in through there. And looking at the changes that have happened over the water year, it's been exceptional. So we're moving from conditions where we did have areas without drought or predominantly abnormally dry into now predominantly moving into those extreme and exceptional droughts. You can see that the last time Maricopa County had that exceptional drought was in July 2021. We had come through from the end of summer 2020 into a very dry winter and moving into really a lot of exceptional drought across the state. Hopefully that doesn't happen again, but this is what we're looking at right now. And then one of the things that we want to consider is, maybe how April might end. And it's not looking so bad when we're looking at this 8 to 14 day outlook. We do need to pay attention when we do get that spring precipitation. That can build wildfire fuel in the form of grasses and brush. And that then can be impacted when we have our more active human-caused fires in Arizona this spring and early summer. When it starts to hit June, we start to get the monsoon activity. That's when lightning tends to be the trigger for most of our wildfires at that time, but it can always change. Every summer is different. But we should pay attention to what's going on with that wildfire potential across Arizona. You can see moving into New Mexico, California, all getting that potential into May as we start to dry out and warm up. And that fire activity, when we're looking at that activity, really the controls that we look at for that wildfire activity, looking at that precipitation from winter and spring, and it's been exceptionally dry for the most part, looking at our spring temperatures. Right now, we're a little bit cooler than normal, so that is good. But that fuel loading plays a role into what happens with our wildfire activity. And drought plays a role, looking at climate patterns, like what happens with the monsoon season. You can see for the year to date in Arizona, we've already had, and this is up through April 1st, almost 300 wildfires. And you can see that that is much larger than what happened to us last winter. Last winter was actually a wet winter, if you want to go back and take a look at that number. But current conditions, we do know that drought is persisting. This is a very active, windy time of the year. April, we get a lot of our maximum amounts of when we're looking at monthly wind activity, typically in April, that happens quite a bit across the state. And with the fuel loads, the Mogollon Rim, when we're looking at the activity and where the wildfires were previously, there's a lot of fuel load right now on the Mogollon Rim. So we need to pay attention to all of these considerations. And what is it looking like when we're starting to look for the monsoon setup? It's not too early to start consider what may happen here with the monsoon season. And we do pay attention to this. It's, kind of into late April, early May, we start to have better science for looking at that monsoon setup. But we're starting to see this happen where we're seeing the kind of green come out in Arizona, New Mexico, May, June, July as that outlook, that potential. The conditions that we look at and consider when we're looking for that potential impact for a more active monsoon season, looking at those dry soil conditions, the outlook here when we're looking at the seasonal precipitation from the CCP or the CPC, excuse me, those dry soil conditions across the Great Plains. For us, one of the considerations that we look into is how dry was it across the lower Colorado Basin, the upper Colorado Basin? Because if we've had a really dry winter, then the conditions may set up where we can get that monsoon ridge a little bit earlier, maybe in the correct place. We'll see if this can happen. We had a wet summer 2021 and summer 2022, and the CPC actually had that outlook saying in 2022 that it would be a wetter monsoon. So fingers crossed, we'll all keep paying attention to this. We love watching this, and hopefully we'll have more conversations about this. But I do want to introduce Rob. Rob, you can go ahead and come on and make sure everything works for you. Rob is the Science and Operations Officer for the National Weather Service in Flagstaff, has some great information to talk about considerations when we're looking at fire activity. So I'm going to stop share, and Rob, you should be able to go and share yours.
All right. Yeah. Well, I appreciate that introduction. And yeah, again, my name is Robert Rickey, and I'm the Science and Operations Officer here in the National Weather Service office in Flagstaff. I'm also an incident meteorologist, so that means I have special qualifications. So I go out and I'll provide on-site weather support for large wildfires. So I do a lot of briefings. I'll make kind of very targeted weather forecasts for crews, keep people safe, to help design tactics around containing the fire. And so, a lot of my background is in fire weather, and it's certainly the thing that I'm the most passionate about. It's really the most rewarding part of my career has been the work that I've done with fire. So, with our conditions, obviously, we've had very dry conditions recently. We've had warm conditions, and so people are very nervous this year about the potential for an active fire season. We've seen the forecast, so thought, hey, why not give kind of a very quick kind of rundown on some of the weather elements that, really kind of drive fire behavior. Now, this will be a quick one. I'm only going to dig into a few different kind of the weather elements. There's many that I'm not going to talk about, but heat and dryness, wind, and then what we call atmospheric stability are three that they're very common in fire weather forecasting, and we know they have a very significant impact on fire behavior. So hot and dry, those are obviously very intuitive to most people. We're talking about when we get very very warm temperatures and very low humidities. The atmosphere is basically thirsty, and it sucks moisture out of our vegetation, out of our forest fuels. Those when we talk forest fuels, many times we're talking about kind of the dead and down that's on the forest floor. So sticks, needles, larger branches. Those are the things that tend to carry the fire. And so when we're seeing very hot and very dry conditions, those dry out and they make them more, makes it easier for fires to start and then also to spread as well. Of course, wind's going to be a big one. Strong winds do several different things. They push the kind of the flame forward. They can start to preheat the fuels out ahead of the flaming front, making them more likely to ignite. They also strong winds lead to faster rates of spread. They can cause spotting. So that's like burning material that's pushed out ahead of the fire that starts new fires out ahead of the flaming front. And then atmospheric stability. I know many of the people on this call are very familiar with atmospheric stability, but for the folks that don't have a strong MET background, that one's a little bit different. It's not quite so intuitive. We'll talk a little bit more about that. But when we have an unstable atmosphere, we tend to have increased fire activity, and when we have more stable conditions, we tend to have less intense fire activity, which again we'll talk about here shortly. So starting out with hot and dry, the hot part, again, that's very intuitive. What are we talking about? We're talking about basically warm temperatures, hot temperatures. They do a few different things. When we've got a lot of sunshine, when the temperatures are very hot, we start to preheat those fuels, and that raises the temperature and gets us a little bit closer to the ignition temperature, making fires a little bit easier to start. But I'd say even more importantly, when you have hot temperatures, you tend to dry, again, the vegetation or that dead and down fuel on the forest floor more quickly. And that's important because you're not really going to burn this forest floor material if there's moisture there. So what we need to do is we need to evaporate that moisture first using heat. And then once that happens, then those fuels become available to ignite. Again, dryness, that's very intuitive to most people as well. One way that we measure dryness in many different ways, but the most common way is going to be dew point. That's the one that most people are familiar with. And that's basically a true measure of how much moisture is in the atmosphere. So when we have very high dew points, we have more atmospheric moisture. When those dew points are low, we have lower atmospheric moisture. So when we have low dew points, again, that tends to dry. That implies that we've got less moisture in the atmosphere, and our fuels tend to dry out much more quickly. Again, when we have low dew points, making them more available to ignite. Now, in the fire weather community, we actually don't usually talk about dew point very often. The traditional measure that we talk about in terms of moisture is relative humidity. When relative humidities are low, again, it implies that our atmosphere is thirsty, and it's going to start sucking moisture out of our fuels. When our relative humidity is high, there's going to be less of a drying effect. And relative humidity it's a very useful measure. I didn't want to include that in this presentation because we actually have one that's a little bit better. And it's one that's working its way more and more into the fire community. And it's a little more complicated, but it's not that complicated. And we refer to it as vapor pressure deficit, or VPD. And I'm not going to get into the details of how we calculate VPD, but what it does that relative humidity doesn't do is it does a better job of including the impact of how temperature will dry forest fuels. So again, when we have very high temperatures and very low dew points, we're going to have a very high pressure deficit, vapor pressure deficit, and we're going to quickly dry our forest fuels. And when that happens, of course, the fire danger goes up. Now, the diagram I have on the kind of screen here, the only point I want to make here is that there's this exponential relationship between vapor pressure deficit and temperature. And so what I mean is this. So the reason why relative humidity is not quite as useful as vapor pressure deficit is for the same temperature, you can have the same relative humidity. So you could have a temperature of 50 degrees and you can have a humidity of 10%, which is very low, or you can have a temperature of 110 degrees and a relative humidity of 10%. So the same relative humidity, but you're going to have vastly different, very large differences in vapor pressure deficit. When you have a temperature of 110 degrees, you're going to see much higher vapor pressure deficits because of this exponential relationship between vapor pressure and temperature. So again, I don't want to get into too many details there, but the main point is, when you have a very high vapor pressure deficit, your fuels are going to dry out very quickly, and that's going to lead to a higher fire danger. And then, we can look at vapor pressure deficit seasonally, and what you'll find is during, our traditional fire season, which is basically the May and June timeframe, that's when we're going to have our very warm temperatures. June's oftentimes going to see the warmest temperatures of the year. What I have here are the normals for Flagstaff, Arizona. And you're also going to see very low dew points. And so we're going to have very, very high vapor pressure deficits. So during this May and June timeframe where we're getting kind of the least precipitation that we get throughout the year, we have a great combination of dryness and warm temperatures. That's when we're going to see our lowest kind of seasonal vapor pressure deficit. So that goes a long way to explaining why we have a fire season in May and June in Arizona. Because we're going to see those higher vapor pressure deficits. We're going to have our lowest fuel moistures and our highest fire danger. So that was hot and dry. Now we can kind of transition over to wind. Again, wind's another very intuitive element for most people. We experience wind, on a daily basis. It's just literally the horizontal motion of air. And of course, it has a very significant impact on fire. I usually kind of put it very simply that the wind speed tells you how quickly the fire is going to move, and the wind direction tells you where it's going to go. And so again, wind pushes flames forward, and that we can start to preheat fuels out ahead of the flaming front, making them more likely to ignite. And then also when we have very strong winds, we're going to be just pushing that fire across the landscape quickly. We're going to be causing spotting. So that's, again, those are embers that are, flammable material that's pushed out ahead of the flaming front, and that creates fires out ahead of the main fire. And then wind direction, of course, that plays a major role in what's going to kind of steer the direction of the fire. Fire tends to move in the direction that the wind is blowing, which is great because that helps, people like me. It helps our firefighters predict where the fire is going to go next. One of the most kind of fun or interesting aspects of being a fire weather forecaster is, we're forecasting on a very fine scale. And so sometimes a fire is burning in maybe a small drainage or on a ridge top. And so I need to make forecasts that are very, very dialed in, very, very local scale. And so we have to pay a lot of attention to all kinds of different types of wind patterns, especially during the Southwest when we have high pressure in place during the fire season. We're going to be dealing a lot with what we call like terrain flows, and we call like upslope and downslope winds. And these are going to occur on a regular basis, on a daily basis. We refer to that as like a diurnal cycle or a daily cycle. And what happens is during the daytime, the winds tend to flow upslope, and at nighttime, they tend to flow downslope. To put it very simply, you can think of it like the sun heats the slopes of the mountains heat the air directly above them, and the air rises. And then air comes in to replace that rising air, and you get this kind of upward motion. At nighttime, the mountain slopes cool. They cool the air directly above them. That air becomes more dense, and that air is going to flow down the mountain slopes just like water would flow down a mountain slope. So it's a very common pattern: upslope flow during the day, downslope flow at night. Firefighting crews are very aware of this, and they'll actually design tactics with these types of slope flows in mind. So The graphic I have on the left is just a very quick video that I took on a fire I was on called the Mangum Fire a few years ago around the north rim of the Grand Canyon. This fire is obviously burning in this mountainous terrain. And you can really see this upslope flow has developed as you can see the smoke kind of flowing, clinging very close to the Earth's surface and just flowing right up that slope. And so that's something that we would see day after day after day after day. Another type of wind that I want to talk about that's very, very impactful here in the Southwest is thunderstorm downdraft winds. Now we tend to deal with these right kind of quite often toward the end of June, early part of July. We start to get a little bit of monsoon moisture in. Maybe it comes in the mid levels. We've got enough moisture for storms, but the low levels of the atmosphere are very dry. And that's basically like the perfect recipe for these very strong downdraft winds. We could go into many details about how these things kind of form in the atmosphere and how they work. But to put it very simply, just think of it like this. We're taking moisture near the surface or in the mid levels. We're pumping it up into the upper parts of the atmosphere. We're forming our thunderstorm. All that moisture has weight. And these updrafts are suspending that moisture in the atmosphere. Well, something happens. That updraft weakens, and all that moisture then, due to the effect of gravity, is basically falls back down to the Earth's surface. And as that moisture is falling, it's pulling air down with it. And that air hits the Earth's surface and spreads out in all directions. And that's what we refer to as these downdraft winds. So they're very, very gusty winds. And they're important for firefighting, because when that happens, we can often see big increases in wind speed, and we can see unexpected changes in wind direction as well. So this time lapse is from a fire that I was on a few years ago in Southern California called the Quartz Fire, and it's burning in this kind of valley that you see. And you can see that the wind is generally going from the right side of the image to the left side of the image, but we have enough moisture for clouds and even some thunderstorms. So a thunderstorm forms to the left of this image, it collapses and pushes an outflow, and you'll be able to see the smoke column completely change directions, implying that this outflow goes through right here and causes a rapid change in wind speed and wind direction as well. So this is the type of thing, this is why we have meteorologists supporting wildfire operations, is because they need to know when these types of things are going to occur, because these can pose a very significant threat to firefighters and also kind of control efforts as well. And so the third concept I wanted to talk about is atmospheric stability. And this one isn't quite so intuitive, right? You don't really, when you're watching TV and getting your weather report, usually we're not talking about, well, what's the state of the atmosphere today? But the atmospheric stability does play an important role in regulating fire activity. And oftentimes what we'll do is we'll talk about the atmosphere and we'll talk about like unstable conditions or stable conditions. What are unstable conditions? Basically our atmosphere is unstable when it is encouraging the upward or downward motion. So when we have an unstable atmosphere, we can get very strong updrafts. And those updrafts, if there's enough moisture around, can lead to things like thunderstorm development in the afternoon, all kinds of different types of fun weather. Unstable conditions are important for fire behavior because this rising air, these strong updrafts, can carry heat and smoke upward. And that allows the fires to become more intense. In one way, you could think of it like it allows these fires to breathe. We're kind of supplying these fires with this fresh oxygen and really just kind of aiding the combustion process. Stable conditions are kind of like the opposite of that. When we have a stable atmosphere, the atmosphere is inhibiting like kind of, we'll say like upward or downward motion. Air maybe is forced to rise or is heated and wants to rise, but pretty quickly it encounters these stable conditions and that air stops rising. So we don't get these strong updrafts and downdrafts. And so when that happens, smoke can get trapped near the surface, and this stable conditions often tend to kind of limit fire growth. It also reduces visibility and air quality, right? So we can trap smoke and pollutants near the surface, which those actually bring their own kind of unique set of hazards as well. Related to stable conditions are what are referred to as inversions. And inversions are these layers of warm air in the atmosphere. And you can think of these as like kind of a cap. And so what it does is it again, it's inhibiting kind of updrafts. And so what we do is we ended up trapping smoke near the surface, and it also tends to limit fire activity because it inhibits fresh air from like making it to the fire, really allowing that fire to breathe. However, there is this kind of, at times we can encounter this very unique situation, and that is this. We tend to break these the most common type of an inversion that we see is one that forms at nighttime called a radiation inversion due to cooling. And then during the daytime, as we heat up, we break these inversions. And this can cause some pretty, because this can trigger kind of sudden increases in fire activity and rates of spread. So as a fire weather forecaster, quite often when I do a fire weather forecast, I'll talk about when is the inversion going to break, so that people can anticipate, that we could see an increase in fire activity when that happens. So what I wanted to do is just show you a video of what the atmosphere looks like during unstable conditions. And again, on an unstable day, we have the atmosphere is encouraging kind of like the upward and downward motion of air. So we can develop these very, very strong updrafts. And basically, we can get all the fun weather. We can develop things like thunderstorms in the afternoon. And that's what we see here. So this is a time-lapse video. We're looking at the San Francisco peaks here from my office in Flagstaff. And you can really kind of see by watching kind of this cloud form, these updrafts as we're taking moisture in the lower parts of the atmosphere and we're pumping it up into the upper parts of the atmosphere. So when we're dealing with these unstable conditions, we'll get these clouds, these cumulus clouds that have this great vertical extent. And so what we're doing here is we're actually forming a thunderstorm. We'll start to see a rain shaft develop now kind of on the left-hand side of the screen. It's a little bit hard to see, but we're getting some rain and a downdraft. And you can see at the upper part of the storm is now hitting the upper part of the atmosphere, and we're developing a thunderstorm anvil. So point is, when we're dealing with unstable conditions, we're getting these strong updrafts, and we can see cloud cover that develops that has that great vertical extent. And we could also look at, what does the atmosphere look like on stable days? And that's going to be quite often very, very different. We're going to see clouds with less vertical extent. They're going to be kind of more flat like clouds. And so this is another kind of time lapse looking at the San Francisco peaks. And what you see is the atmosphere in this case is not encouraging the upward motion of air. So let me play this video again. Like if we really focus in on the San Francisco peaks, you can see this moisture kind of moving from the right side of the image to the left side of the image. It's rising over the mountains, but then quickly descends on the other side. So we're not getting those strong updrafts. And again, that's leading to cloud cover with less vertical extent and more kind of the flat appearance like this. So this is an indicator for folks in the field. So for firefighters, they're trained to kind of assess the conditions based on the appearance of the atmosphere. And then from that, they can start to think about what that might imply for the fire activity for that day. So the final thing I wanted to show is inversions. And so what I wanted to show is a more kind of dramatic example of what happens when the inversion breaks. I'm going to show a time lapse from a fire that I was on a few years ago in Southern California called the French Fire. And most of the time, the fire activity doesn't necessarily respond in such a great way to the inversion break. Sometimes most of the time what you'll see is the smoke column rising to higher heights and things like that. It's not necessarily like a very significant hazard for firefighters, but sometimes it can be. And this one was in this case. So we'll start this time lapse. So this is the French Fire. It's burning in these mountains here. You can see the smoke column going from the left-hand side of the image to the right. There's some type of an inversion keeping that smoke close to the surface. And then in kind of the early afternoon here, very shortly, you're going to see as the inversion breaks this wind shift here and a big increase in fire activity. In fact, the fire activity was pretty extreme after this inversion broke. Folks in the field reported fire whirls, which are kind of like, I'm not going to call them a fire tornado, but they're very kind of dangerous, like circulations that develop that the fire kind of resembles what you call like a dust devil. And but the main issue here is there's a little community in the base of these mountains called Wolford Heights, and when that inversion broke and the wind shifted, then the fire started spotting into that community, and the firefighters had a tough time really just trying to keep people safe and trying to protect the structures when that inversion broke. So good news is there we were aware that the inversion was going to break. We could see this kind of occurring roughly the same time every single day, so it was well forecasted and people were prepared for it. But it just shows how impactful these inversions can be, especially when these inversions break and you're changing from stable conditions to more unstable conditions. And that wraps up the presentation. Again, it was a quick one. There's many different elements we could talk about that do impact fire behavior, but when we're talking about those primary elements, it's going to be your hot and your dryness and kind of how those combine and their effect on forest fuels. It's going to be, of course, your winds, and then it's going to be the present state of the atmosphere, whether or not we're dealing with stable or unstable conditions.
All right. Thank you so much, Robert. That was exceptional. We really appreciate that.